Hey, it works. Hi, welcome to the show. Welcome to me having audio and everything. Thanks everyone for stopping by. It's time for John Park's workshop. Here we are. And first of all, I want to thank the people for stopping by our chat. We've got YouTube chat and we've got the Discord, and that's the main place for chatting with Adafruit people during shows, or even not during shows. Head on over at adafruit.it/Discord and jump into the live broadcast channel, live broadcast chat channel. And we've got, you can see right there today, a whole bunch of other channels too, with different interests in mind. So check that out over at our Discord. And oh wow, yeah. So sorry, there was a bunch of white noise, huh? Yeah, I had this mic pack off, and for some silly reason, when the transmitter pack is off, the receiver pack makes a bunch of noise, which I apologize for. That's annoying. And I said we've got the YouTube chat, but I don't have it popped open, so let me do that so I can see it. Hey, Gary T, I see you over there on our YouTube chat. I'm just going to pop that out right here, right now, and now it shall persist. So let's get on with some things. First of all, in non-Adafruit news, I was excited to learn this morning from this press release. Wrong one. This one here, yeah. General Mills is coming out with a limited edition of redesigned Monster cereal boxes, which have art done by artist Cause, K-A-W-S Cause. And Cause has the famous sort of panda guy with the bone ears and the X's for eyes. So there's going to be a set of Monster cereal boxes that have the X's for eyes in a redesigned retro style packaging, in honor of which I'm wearing my Boo Berry shirt today, which is the best Monster cereal. But I don't know if they have it listed here, maybe not in a photo. Oh, there it is. Fruit Brute is coming out. Fruit Brute hasn't been on the shelves in like a decade, so get ready. I'm assuming this is Halloween stuff. This has been your free, non-sponsored media blast for General Mills Monster cereals. Very excited about those. Are you excited about those? Also, we have a jobs board, so if you're looking for work to pay for all that good Monster cereal, or if you need to hire someone to help you get through all the Monster cereal, then head on over to jobs.adafruit.com. Here it is. It is entirely free. Head on over there and you can post in our job board. It's free. You can also post, if you're looking for work, your resume over in the Available for Hire section. If I click over there, I think I'm logged in today. You just have to be logged in. It doesn't cost anything. There's no spamming of anything, but as long as you have a login, you can use this service. All of the job positions are vetted through Lady Ada and PT, so you know they're good. But here's a sort of sample of people who are looking for work, have posted up their info, and these are very often remote. People want to do contract work and freelance work remotely, or even full-time or part-time work remotely. So don't worry too much about where they are, more about what they can do for you. So that's at jobs.adafruit.com. Let's see, what else? I have a show on Tuesdays. Logo looks like that right there. It's JP's product pick of the week. Here's the thumbnail from this week. And what I like to do on the show is a product pick, which is going to be massively discounted during the show. So just throw it in your cart. There's no need for a coupon code. You can get that product for, in this case, half off. We sold through about 100 of these at half off prices. And I'll usually do a demo, sometimes a software demo, a hardware demo, show you how it works, give you some backgrounder on it. And here's a little excerpt from this week's show. It is the motorized slide potentiometer. But you can see the cool thing is we can play around and then let go and get back to our preset position there, thanks to the motorized fader. We can also go to other presets. So if I click my encoder, I can go to a different preset. Hit another one, and these are just 4 positions that I've pre-programmed. I've set up my rotary encoder as a direct control there, so you can see as I turn the rotary encoder, I'm changing the position of the fader. I'm also using that as a stored position. So now if I hit this 4 times, it'll come back to this position. I have 4 saves. So 1, 2, 3, before, back to that new position. It is the motorized slide potentiometer. And that's it indeed. Love to see the projects people are going to do with those. We got a bunch of them out there into the world. I think I showed last time, I've got this Learn guide here that I put out, which is the basics of using these motorized slide potentiometers. I'm going to be adding Arduino code to it as well, and a update on how to use the motor feather wing instead of a H-bridge chip, sort of bare L9110, which is what I used for the original project. I demoed this, I think, on a show and tell last week. Yeah, I can't remember now, but I may have an update on the update, which is, let me go to a down shooter here. How about like so? Let me put this under here, and we'll go on and move forward in a second with another segment. But I just wanted to make sure I let you know that I was successful in getting a Chrome conductive slide cap. Oh, it's not powered on, so that's not going to do anything. Let me plug this in. Since this has capacitive touch on it, you can do things like move to a position when you touch it or turn off the motor. It's the most likely use. If I power this up, and let's see, this might be, there we go. So you can see I'm now using, instead of the bare, pull this off of here, the bare lever stem thing, which in itself is connected to the cap touch pin. This is a chromed plastic fader cap made for this purpose. I think it's a replacement part for a Yamaha mixing board, and it works great. You can tell it's letting the motor go as soon as I touch it. So we're trying to source those. Lady Ada was looking around to see if she could find those. We are also, don't ask, don't tell, but we're probably going to be getting some sort of regular rubber fader caps that fit this this type of potentiometer, and I will make some attempts at using some copper tape to wrap inside and around it, see if that'll work well as an alternative. So as long as it's capacitive touch, it'll work. I was not able to get it to work with a very, very, very low threshold through another material, but I'll give it another shot with the plastic or rubber caps that we get. So that's the update on that. It is made of plastic. Yeah, it's a conductive chrome plate. A lot of chrome paint. That was a question, by the way, from Todd in the chat there. A lot of chrome paint does not conduct. I tried it with some really good chrome paint pen paint, super shiny, reflective stuff. It was not at all conductive, but this, however they're doing this process is, so we'll see if we can come up with a source for those. Let's actually, before we go any further, dive ourselves right into this week's CircuitPython Parsec. CircuitPython All right, let me do a little setup here and grab my window. So what I wanted to show today for the CircuitPython, let me say that again. What I want to show today for the CircuitPython Parsec is how to use a new line when printing to serial instead of the default carriage return. No, wait, do I have that backwards? Yeah, starting again. For the CircuitPython Parsec today, I wanted to show you how to use a carriage return instead of a new line when you are printing to the serial output. So here's an example of a free-floating analog pin that I'm reading. And you can see here as I touch it, I see numbers go by, and I have a neat little print statement going that gives me sort of a graph of the values that I'm getting as I touch this analog pin here, sort of grounding it. But that's hard to read because we have these characters flying up the screen. And the reason for this is that the default in the print is to end with a new line, which means it goes to the beginning and adds a new line for every print statement. If we change this instead to a carriage return, or a return, what happens is it goes to the beginning after each print statement, but it does not add a return. It does not add a new line return. Instead, is just this carriage return. And so you can see here the way to do this is if I take a normal print statement and add to the end of it this here, comma, end equals, and then in quotes, \r, and that's the return or carriage return. The default, if I don't have that in there at all, or if I change that to n, looks like this. And so we get this sort of string of characters flying by, or a string of lines flying by. This instead is a lot more helpful for measuring values and seeing them without getting endless scrolling of your text. The other tip that's going on in here, a little bonus one, is I want a bunch of these dashes at the beginning, and you can actually multiply text by a number. So I have a number of dashes multiplied by whatever the value is, and my value right now is, I think, going from 0 to 128 or something like that, 0 to 64. So when I am up here at a high number, I get a whole bunch of these dashes in there without having to type them. So you can do some math on your strings, which is pretty cool. But this is the key thing here, is this end equals \r. And so that is how you can use a return instead of a new line when you're printing to serial output inside of CircuitPython. And that's your CircuitPython parsec. And yes, I actually, thank you. Yes, Dexter said they like the Blueberry shirt. Blueberry forever. See, Grover had a suggestion of maybe drill a tiny hole in a fader cap and use some metallic epoxy. Also an interesting idea. Hey, Rich Sad, nice to see you. By the way, this may look familiar, this little tip that I did today with the CircuitPython parsec, because I had a similar setup going. Let me unplug this, and I'll replug in my fader here. I can put that on camera. Let's see if it connects to this one. I think I gotta reconnect because it has a different name. Yeah, that's right. So let me, Disco Tool. It's the feather. Okay, yeah, it was a different. Disco Tool -N. Fe. There we go. So here you can see this is actually kind of the more typical behavior. That's just because I have a narrow window, so I'm getting sort of automatic looping around. If I widen this up, there you can see that's the behavior we're looking for. It just makes it a lot easier to see what's going on. It doesn't give you a history like a endless scroll does, but in a lot of cases, this is really snazzy, really helpful. And big thanks to Todd Kurt for both the multiplying your text, in this case the dashes, that tip, as well as the new line versus carriage return tip. Really useful, so thanks for the good stuff. All right, so let's see. That covers updates on the fader, comes our CircuitPython parsec. So I want to start getting into this coffee scale project. So let's back up a step. Let me see, do I have a little prop here? So this all starts with these two things. So one, we've got these load cells, and these are a piece of aluminum bar that's been carefully drilled and calibrated with this arrangement of resistors, this sort of S-shaped arrangement of resistors called a Wheatstone bridge that can measure the flex of this metal bar really precisely as a an analog read on an amplifier chip, an ADAC chip rather, that can deal with the very, very, very low values coming off of this, make it useful. So this is our, what is it, the NAU 7802 is the chip we're using. Cedar Grove, our good friend over in the chat there, created a feather wing with this chip on it that I believe reads 2 of these at a time. And then Lady Ada had been working a long time ago, and then we had parts issues. We've been working on doing a standalone single channel with Stemma QT. So I'm using this, but I'm also going to be building a version using this feather wing that Cedar Grove made to read this sensor, which is what's inside of a scale. Most scales use this type of an arrangement. The neat thing about it is that with the library and code that Cedar Grove has made for us, we can make really nice scale displays. We can tear to remove weight from a vessel that you're putting on that you're going to pour something into, in my case, coffee. Add some nice graphics, do a bunch of things that'll run on the Clue, on I think a TFT Featherwing, on a PyPortal, maybe a couple other platforms. So it's great time to be making scales. The challenge I had, really, because all the heavy lifting was the stuff that Cedar Grove Maker had built. Real challenge is mounting this in a way that's useful for your use. So key thing is, these can't be resting on something because we need one side of it to flex. The other side needs to be really stable, locked down. So they put these threads for an M5 screw on the sort of stationary end, and they put M4 screw threads on the flexing end, and then it's up to you to figure out how you're mounting that to your enclosure, how you're mounting something like a tray that you're going to set your weight down on top of to this side. So I wanted to show kind of my process for coming up with this Espresso scale. I also want to talk about why. What are we doing this for? So when you're making espresso in particular, you can really get a lot of change in how things taste with some very, very minute changes in the fineness of your grind, the amount of coffee that you put into the portafilter, which is this thing, the basket that goes into the machine, gets chucked in there like that, and then a lot of hot, high-pressure water goes through. Tamping that evenly, having an even grind, all of these things change the extraction, because we're doing an extraction of a whole bunch of these solids out of the coffee with the water that's coming through. If you can reduce the number of variables you're dealing with, you can focus on the ones that really matter, such as changing your grinder settings. So what I want to do is pour a consistent amount of coffee in a consistent amount of time, and that allows me to focus on just adjusting the grind. There are other variables you could deal with and lock others down, but weighing your coffee is a really great way to do this, and you'll see a lot of high-end coffee people and baristas using little scales that they'll set underneath the machine as they're going, and then they can take that off and proceed. So I wanted to build something like that, but kind of make it a little bit more permanent. And so what I'll do first is let me show you a little video of part of this process in action that I took. I shot earlier. You can tell by the blueberry shirt reflected in my espresso machine. So check this out. This is about 27-second pour, which is usually what I'm going for my double basket. I just wanted to, sorry, thanks for wait. I just wanted to minimize that video there for a second so you could see it. It's hard to see it at this scale, but what I'm watching there is on the little clue there on the display, there's a little gauge moving up and down that shows at the bottom both grams and ounces of weight that it's reading. So if you watch that, you'll see that number going up. All right. So one thing I'll mention is that I don't have a lot going on with sort of splash proofing yet, and so there's some electronics sitting a little worryingly near some water, but not too close. The ADC and the clue, and I'm using batteries, so it's not plugged into the wall, which is a bit safer. Those are a little bit removed, and then everything else is just the load cell, which you could protect. It's got silicone over the wiring, and the rest of it's all aluminum. So let me show you. Oh, someone found Lars. Little Lars alert. Let me show you over here what this is looking like and what my process has been for putting this together. Let me throw a bench or a main view. There we go. Let me scale that down. All right. So what you may have seen when I first posted this, let me see my water over here, or first started showing some demos of this, was one of these helping hands. This was actually a really nice base for this. We actually sell these in the store. It comes with some magnetic PCB holders, as well as these two helping hands. And I was able to just use this slot here and some M5 screws with washers to mount the load cell here. So I'll take off these for a second. This was a really expedient way to get a prototype working and a little more stable than me just kind of holding things in my hand there. And so I'd recommend, if you can get some trays or boxes of M4, M5, M2, M2.5, M3 screws in a few different lengths, you can tackle a lot of these projects. Ideally, they're all metric. They're not always. And so here are some M5 screws. Zoom in a little for you there. So I was able to put those up through there. Put a nut or a washer over top of that just to, oh, actually, no, I didn't. Did I need to? Yeah, just to get a little bit of space so that the other side is elevated up. So you can see, I just put a nut right there that you can see. So that's going to give me some space so that when this side flexes, once this is screwed in tightly, it's not bumping into anything. So I will just attach one side of this just to show it off quickly. Oh, that nut got caught in there though. Let me try that again. Yeah, I wish I had an actual washer, which is going to work a lot better. Okay, I'll for this sake of this demonstration, we'll pretend there's a washer there. By the way, one thing that bit me recently is these have a little arrow on one end that tells you the sort of size of the load cell. Is a 1 kilogram, and a down arrow, so it's saying flex it that way. So that means the other side here where the wiring is coming out, at least on these ones, this is what you'll mount, and you'll want your weight pushing down on the direction of that arrow. That's the ideal. I think it'll still measure it in the other direction, but you might have to screw with your wiring to get that right. So it's basically like that, except with a little spacer in there. And then you've got these M4 side to connect something that you can set your weight on. So I had just taken a little piece of acrylic here and drilled a hole in it and mounted it like this at first. So that was kind of the version that I was using during my development of this. And this would work pretty well. You could refine this and then just have a little gizmo to put on the Espresso machine set under there. That would work great. That's a lot more like a traditional scale. However, I wanted to instead make this sort of integrated with my machine. So as you may have seen from the image there, there's a large drip tray this right here. And unfortunately, I can't bring my machine. It's plumbed in to my water and water filtration and wastewater and all that. So it's a big pain, big heavy thing, and I don't want to unscrew things and move it into here if I don't have to. So this is the drip tray, and it means any water drips through, comes and exits through a little hose to the wastewater. And this is this little mesh that sits on top of that tray, and that's normally what you set your cup down on top of under the spout, and your portafilter and brew head and all that are right above it. So after at first just setting a thing in here like this, that worked pretty well, but it also did elevate the height of my cup to a point where I couldn't even fit, I don't have one of those here, but I couldn't fit a spouted portafilter. So some of these will have a spout coming off of them or a double spout coming off of them. And as you start eating up space above here, it gets a little crowded in there. So I wanted to go as low profile as I could. And you can see here, in the end, I'm really just adding this inch or so of space. And you can see I've got this kind of floating scale that is mounted to this steel grid. This is strong enough that it's not flexing, which is great. We don't want the whole thing to flex on us, or we won't be able to measure the weight very well. And so I've mounted a mounting point to it, the load cell, and then to the load cell this little floating piece of aluminum, on top of which I can put a little, here's a nice little Adafruit coaster. All right, set that down there. Could maybe use some, if we wanted to, some magnets or double stick tape or something like that so this stays on there. But that works well, gives us a large enough surface area to not have to be so precise. And it's all easy to wash, easy to care for. So then over here, this is at least temporarily, and I might do the guide based on this setup, I have the clue with our little acrylic case for the clue. And that makes it a little more splash proof. It's not waterproof, but it also gives me something to affix things to if I want to use like double stick tape and attach it to some other type of mounting point. I'm just using a nylon screw here, which is working well. And then an extra long screw on the back means that I have a place to connect the little ADC board there, STEMMA QT ADC board. And then finally I've got battery power. I'm using 3 AAAs, and I stuck the lid of the case just using a little of that U-glue sort of double stick goo tape squares. And that means I can slide the battery pack into here, so it'll come off for changing, but I also have an on-off switch there, so I can turn this on. And it'll boot up here. Unfortunately, at the angles I have things, you won't be able to see me actually weigh something too well, I just realized. But maybe we can fake that. And so here it's booted up now. I am using, actually, sort of by accident, I'm using a 10K load cell on here, so it's a little bit noisy. You'll see this value fluctuating a little bit. I can hit the tear button, kind of get it back to 0. But this is a bit of a noisy value here because of that load cell being 10K, and we're trying to read at this very amplified level. So 1K is more stable than that one. But you can see, sort of see here, I'll fake the angles a bit. If I set my cup on here, yeah, that'll work, I guess. 264 grams or 9.3 ounces. So I'll go ahead and click that button that zeroes it out or tears it. So now it's essentially at 0. And I'll zoom in a bit. So you can see down there in the bottom corner, it says coffee. And the way I'm leaning this here means we're not really getting accurate readings, but I don't have a good way to... Actually, you know what? Let me just take I'll pull this off. Let's do that. I'm going to unscrew the the clue from here, and then we can look at the values that we're getting. So this is just a nylon. This is actually the nylon screw that comes with this case, this clue case here. Okay, so we'll set that there like that. There, now you can see it. Just refocus. Okay, so I'll zero that. And then you can see here, simulate pouring the espresso in there. The scale goes up and up and up and up. And you can stop wherever you need to. And you have to anticipate that a little bit with the espresso machine just because you get some extra coming out after you pull it. So there's some finesse to getting that. But it's a scale. It's really well integrated, I think, into the machine itself now. I may use a little OtterBox or who knows what to seal this up better. Another suggestion, actually, that Jan had, Cedar Grove maker, was to use one of these little sort of security camera tripods. It's a mountable one, and mount that somewhere and use a little thread mount. We have some nice thread mounts for the Raspberry Pi cameras. That might be a good basis for that. If you're doing stuff with a Circuit Playground Express, Circuit Playground Bluefruit, the little case that we have for that also has a thread mount for a tripod, so you can screw that into there. So that's another idea for getting that kind of accessible but off to the side a little bit. But this is working pretty well so far. I've just used it a couple times yesterday and today to make my espresso, and it's been delicious. Sorry I can't share that with you. Some of the details on the mounting stuff that I've got going on here. Let me unplug a couple things from here. And I'll pull this back out. Set that back here. This is all, I think almost all of this is available actually in the Adafruit store, because this is some of our 2020 aluminum plate that you use with this T-slot aluminum. So we have in the CNC section of the store this T-slot aluminum, and similar to 80/20, if you've ever used that stuff. And we have accessories for that, such as these little triple couplers, and that's what I have right here. And we also have some larger adapter plates, which is what this one is. This also one's shaped like this. So depending on your needs, you can use this stuff. It's, I think, this might be a M6 hole, roughly, and so you can fit the M5 and M4 through this nicely. You'll see there's the M5, so that would go onto that side, even if you're just making kind of a cover for this or something, so long as you add a little spacing so that it can still flex, that would work well. So that's all those two pieces are, and then it's a matter of this thing only would accept the M3 screw, so I have just some nuts at the base here and some washers on the other side to lift that up a little bit, give us clearance. Again, this side can stay and needs to stay stable. This side needs to float. So you'll see there, I've got the gap there, and it's a tiny bit. I mean, the flex is really minor that is caused by pouring some coffee into there. Let's see. Let me swap camera views over here. Swap back over to this camera, see if anyone's got any thoughts or questions. And the Todd says he measures his coffee consumption in pints. All right, I get it. The other thought I have is with the feather wing that Seagrove made, which allows you to use 2 cells. I could do both, like grounds, weigh the grounds, and one way that people will work is they'll grind up their beans and then they'll have their dispenser dispense based on weight, and these are usually specialized machines. So you put the portafilter in and then it dispenses, 18 grams of grounds into there, whatever the amount you want to start with, and you can go through your whole preparation process. I tend to weigh the beans or measure the beans, throw those in and just grind one at a time because I'm not doing large scale production. But there you have it. That's the project. The guide is, Jan's been working on the guide. It's looking great. It has code, has libraries, has the graphics you need to do the backgrounds and the scale elements. I'm shooting photos now of the process on my machine. So once we combine those things together, we'll have a really good guide, I think, for you to check out, and can be a launching off point for any kind of scale-based projects. All right, well, I think that's it. Let's see, have I forgotten anything? I think that's all I had today. Thanks everyone for stopping by. Thank you for the people in the chats, both in our Discord and over in the YouTube chat. And I believe we've got a Foamy Guy deep dive coming up, live stream tomorrow. Scott did a guest spot last week. And then we'll start up with our regular shows next week. Oh, here's a nice view, by the way, of PyPortal version of Jan's scale there, and that's the one that I was talking about, the idea of having both your beans and your coffee from 2 different load cells. By the way, a really nice feature of the code is with 1 line of uncommenting, you can go through a calibration process using a known weight and calibrate the cell, just a one-time thing, throw some numbers into the main body of the code, recomment that calibration line, and you can trust your scale from that point. All right, well, that's going to do it. Thank you everyone for stopping by. For Adafruit Industries, this has been John Park's Workshop. I'm John Park. Bye-bye. Don't forget to eat your monster cereals.